Hello everybody, let's give you some information about soft robotic grippers, which is our term project. Robotic grippers and arms are sub-brands of robotic systems. Soft grippers are preferred because of their structures that can move more precisely and exhibit human hand-like behavior. But hard robots have low thermodynamic structure, weight, high cost are some of them. Our robots can grip any kind of material without any damage. The gripper has 25 cm length, 30 cm width and 15 cm depth. The robot has 4 axes which can rotate the body and has an actuator operate via pneumatic system. Also at the tentacle part of the actuator we use pressure sensor which is totally our own design and fabrication. This is the key part of the project. In addition we used a microcontroller STM32 and implemented a graphical user interface to control the gripper. Our graduation project has 3 main parts. They are actuator and sensor design, mechanical design and software design.
Now I will talk about the actuator. At the edge of the robot, there is an actuator part which made with silicone. The actuator provides to grab the soft materials such as egg, tomato, and etc. Our actuator has microchannel in the middle of the actuator. And to grab, we pump air to this channel, then actuators start to blow up and finally grasp the soft material. We need a pressure sensor to determine whether the actuator completely holds the object. Since we are trying to hold soft objects, we should not use a rigid sensor because rigid materials can cause damage to soft objects. Therefore, we designed a completely soft sensor to prevent this damage.
Hi, my name is GÖKHAN. I will talk about the sensor part. The sensor has been observed that by feeding a conductive liquid which composed of elements, we decide after several experiments, carbon black and mineral oil, into the micron channels in a silicon material. The size and shape of the micron channels will change in direct proportion to the applied pressure. This pressure will cause a resistance change in the sensor. In this graph, we want to determine the characteristic of the sensor. To do that, we can show the change of the resistance depends on the external. We also use an air pump to provide airflow. We need to release the air to drop the object. For this purpose, we use a Y connection and connected the air valve. Thank you.
In accordance with the soft gripper robot mechanism, we have designed 4-axis multi-operational robot, which includes 5 motors to drive the robot and to carry the object. It's worth mentioning the fact that all parts of our design belong to our team members and have been designed and printed by using SolidWorks program. In order to achieve rotation softly, we have designed 3 distinct ball bearings to perform the rotation. The ball bearing has 2 coaxial rings and 48 gears located between inner and outer rings to prevent the friction on the axis. And the first axis rotates the robot left and right. The second one lifts or drops the arm of the robot. With this movement, we can lift the material which we gripped. The third axis rotates forward and backwards. In order to adjust the location of the actuator, the fourth axis rotates the actuator around itself.
We use STM32 microcontroller to determine the grasp magnitude and control air pump and control valve and communication with interface. By this control, during the air pump is blowing up the actuator, we are able to obtain the pressure sensor values from 3 different ADC channels. After several operations on pressure sensor data, approximation to the threshold value for grasping has been achieved. That's how we can determine when to stop air pump or not. Likewise, we can determine whether the size of the object is large or small by using a timer to evaluate the grasp time. For large object, we need lower time, and for small object, we need a larger time duration. We also designed the user interface using Python. This interface is communicated with microcontroller via serial communication. In this interface, there are buttons that we control the axis movement and air pump and valve.
First of all, the air pump run, and when all of the 3 sensors touch the tomato, microcontroller stopped the pump, and robot carried tomato.